কল্যাণ কি শুরু করে দেবো এখন না একটু পরে?
করতে পারো, বলতে বলতে আসবে।
ঠিক আছে, 2 মিনিট দেখছি তাহলে। Okay, today we'll be starting with our mini project. This is basically meant for one automated tank filling system. This is fundamentally almost identical to our water watchman problem, which you studied in our digital electronics class, but it is a much more advanced version. Hope you remember that water watchman problem that we studied earlier. Do you? Do you remember that?
Yes, sir.
Fine. Now here, basically, what James sir has given this this write-up, he has described what are to be done in. There should be 2 versions. One is the version 1, which will be dealt today, and version 2 will be done later on. In version 1, this is basically one on-off type of control, where there will be 2 modes of operation. One is the auto mode, the other one is the manual mode. So that means there will be one switch which will indicate in which mode the motor should be now. If it is it should be in auto mode. If it is in zero mode, it should be in the manual mode. Now, when the system is in auto mode, when the pump should become on, logically, what do you think?
So when the tank is empty.
When the tank is empty. But the tank is empty, but in the lower reservoir, you don't have any water. In that case, though there is a requirement of starting the pump, but as there is no water in the lower reservoir, the pump cannot be on. Isn't it? Yes or no?
Yes, sir.
Now, that means there is a requirement of starting the pump, but as there is no water in the lower reservoir, I should indicate that there is something abnormality in the situation. The situation is not normal, so the pump cannot be on. So somebody must take care of filling the lower reservoir first. Then only the pump can be started. Okay. So this should be implemented. But first of all, before checking whether the tank is empty or full, we must have some information from the tank that the tank is empty or the tank is full. So for that, we take help of 2 level switches. One level switch will be near the bottom position of the tank, and another level switch will be near the top position of the tank. Now, how these level switches are operated, for that KM sir has a small video. He will be displaying that. KM, Kolyan, ওটা তুমি এখন দেখাবে না পরে?
পরেই দেখাই, তুমি শেষ করো।
ঠিক আছে। So, but what I am assuming it, there are certain level switches, and if water is available till that level, the level switch is producing a logic 1 output, and absence of water in that particular level is indicated by the logic 0 output from that switch. So presence of water, I am assuming to be 1, and absence of water, I am assuming to be 0. If it is opposite, in that case, in my logic, I'll just simply invert that corresponding input, nothing else. So that can be very easily implemented. So for the time being, I am assuming that the presence of water up to a particular level is assumed to be a logic 1 coming from that level, and absence of water is being indicated by logic 0. So altogether, there should be 3 level inputs for my system. 2 from the tank, 1 for the lower level, second one for the upper level, and the third one is to indicate whether there is water in lower reservoir or not. So from the lower reservoir, I am having a single level output, indicating whether the reservoir is full or empty. Now, there can be another input, which say after you start the pump, what may happen is suddenly due to some reason, some overload condition may occur. That means the high current is flowing or something like that. So that must be avoided. So as soon as that happens, I should stop the pump. So for that, another input is required that will indicate whether pump overload has occurred or not. So logic 1 from this input is being treated to be that overload condition has occurred, and logic 0 indicates that there is no such a pump overload condition. Fine. Now, when any abnormal, by the way, another abnormal situation may occur. Say there is some leakage in the pipeline, or the pump may not be operating properly. So what may happen is normally we know that to fill up the tank, maximum say certain T amount of time is required. Now, if within a certain allowance from this T, that means say let me allow T plus n amount of time, so T plus 5 amount of time. So even after T plus 5 units of time, if the pump is not automatically off, we must indicate that some error has occurred in the pipeline, or some malfunctioning is there. So I must now switch off the pump. So that's called the timeout situation. So that means this timeout situation should also be incorporated in our system. So there may be 3 types of abnormality. One is there is no water in the lower reservoir, but there is a requirement of starting the pump. So that is one abnormality. Second one is there is a overload situation, pump overload has occurred. And the third one is timeout has occurred. So these are the 3 possible sources of abnormal operation. Now, if any of these 3 abnormal operations occurs, so the pump is off, and at the same time, some alarm must be indicated. So alarm must start. So that one operator can now come to this control room, or to this near this pump, and he must find out what type of problem has occurred, and accordingly he must initiate some action. So the after the abnormal situation has occurred, there are 2 types of alarm. One is one visual alarm, the other one is one sound alarm, audio alarm. Now, why is this audio alarm required? Because the operator might be quite a distant. It is not very near to the pump room. So to get alert, to become alert, the buzzer or the sound audio alarm would be more required than the visual alarm, because the visual alarm will be effective only when the operator comes near the pump room. So that audio alarm will attract the operator, or indicate the operator that you have to go near the pump room. And after he comes near the pump room, he finds that one lamp, alarm lamp is blinking. So now, definitely there are 3 possible sources of problem. One is overload, second one is timeout, and the third one is empty sump or empty reservoir, whatever you say. The corresponding lamp should also be glowing. what type of problem is there. So he identifies the problem, then presses one acknowledge switch that indicates to the system that the operator has acknowledged the problem and he is now taking care of the situation. So as soon as that acknowledge button is pressed, that audio alarm will now be off, because the system now knows that the operator has taken is now considering or trying to take care of the problem, and that visual alarm that will now glow steadily. So before acknowledgement, audio is giving sound, lamp is blinking. After acknowledgement, audio is off, lamp it becomes steady. Now the operator has, if that the problem was due to the empty sound, so operator has taken care of that problem, and he is trying to fill the lower reservoir. After that lower reservoir is full, the operator now presses the reset button, indicating the system that he has taken care of the system and the system is ready for the normal operation. So now what will happen is the pump will resume its status. That is, pump was, or if pump was earlier on, it will become on again. And that tank will be automatically filled up and the pump will become off. So now, in absence of any of these abnormal situations, when the pump should become off in the auto mode, in the absence of any of these abnormal situations, when the pump should become off.
If the tank is full.
How do you know that the tank is full?
ওইখানেও ওই মানে একটা লেভেলে চলে গেলে এটা pump বন্ধ হয়ে যায়।
There are two level sensors in the tank. One is the situation near the lower level, and the other one is the near the upper high level. So when that upper level sensor is producing a logic 1 output, we'll switch off the pump. Okay. So I repeat, when the pump will be on, when the lower level switch is producing a what type of output, like 0 or 1? Zero. That indicates that there is no water near the lower level. So that means the tank is empty. So pump becomes on there and the pump becomes off as soon as the upper level is giving you logic 1 output. Okay. So that's what is being described here. So what are the switches and inputs required? One is AM bar. Why is the nomenclature AM bar? This is select between the auto mode and manual mode. Now, why I have given the AM bar name nomenclature?
One থাকলে auto, zero থাকলে
yeah. When this switch gives you logic 0 output, it will be in the manual mode. When it is logic 1 out, giving logic 1 value, it is not mode. Whatever description I have given so far, that was for the auto mode only. Now, when the system is in the manual mode, in that case, the pump can be started by pressing the M start, this motor start switch or the pump start switch, and pump can be stopped by using pump stop or the motor stop or M stop switch. But the pump will be on provided upper level is empty. That means there is no water till the upper level. That constant is imposed here. Okay, so in the manual mode, M start switch will be active if the upper level of the, if there is no water near the upper level of the tank. And the pump can be turned off by pressing the M stop switch. but that's in the auto mode or manual mode. In auto mode, everything is done automatically. This TH, TL, and sump. So as evident from this picture, this TL is the input from the level sensor, which is situated near the lower level of the tank. TH, I have termed that input as the level sensor output, which is situated near the upper level of the tank. And in that sump of the underground reservoir, there is one single switch, S or sump, whatever you say. Okay. There will be three displays showing the abnormal situation. One is the empty sump, second one is overload, third one is the timeout. There will be two alarms. One is the visual alarm, the other one is the audio alarm. Okay. So the number of inputs, one is the auto ember, second one is the manual start, manual stop, and three level switches, TH, TL, and sump. One is the acknowledge input, one is the reset input, and one is the pump overload condition. Now, what are the required outputs? One is